In this problem, we are trying to find the following limit. So this ratio, x to the power 5 minus square root of x over x minus 1. So the limit as x goes to 1. So we see that if we try to plug x equals 1, we get 1 minus 1 over 1 minus 1. It's 0 over 0. So therefore, we can't conclude. Okay? So most of these problems, we can just simplify and use some algebra. Maybe we can use some factorization or some remarkable identities. Like here, the problem is with this square root here. Okay, we can rewrite this expression in a different manner by just trying to factor out by something. Okay, let's see what we can do here. So we can write it as x to the power 5 minus x to the power 1/2. So here we see that we have this power. We have to make the powers appear here, something that's similar to the one on top. So here we can write x as x to the power 1/2 squared minus 1. Okay, we did nothing here, we just divided by 1/2 and multiplied by 2, so it's still 1. So now we can see that we can do some factorization. If we try to factor by this one here, okay, so I think we can do something like that. So when x goes to 1, so let's factor out by this number here, x to the power 1/2. So here we have to subtract it from 5. So 5 minus 1/2, that's 9 over 2. X to the power 9 over 2 minus 1 over x to the power 1/2 squared minus 1. Okay, now with this one, with this rewriting of the expression, we can compute our value. Okay, so in fact we see that we can rewrite it one more time as x goes to 1, the limit as x goes to 1, x to the power 1/2 times x to the power 1/2 to the power 9 minus 1 over x to the power 1/2 squared minus 1. Now we can use our understanding of algebra. So think of this one as some u to the power 9 minus 1 over u squared minus 1. Here we can use some factorization. We can rewrite this one as x goes to 1 of x to the power 1/2. So here we're going to use this one, x to 1/2 minus 1 times x to 1/2 to the power 8 plus x to 1/2 power 7, etc. until 1 over x to the power 1/2 minus 1 times x to the power 1/2 plus 1. Since we get close to 1 but we don't reach 1, we can in this case we can do one more thing here. We can do some elimination, and that's what we're gonna do because this is the problem. So the problem when we had the 0 is coming from this one. So now let's try to plug in. So we get 1 here, 1. We have no problem now. So the limit is equal to this limit here, as x goes to 1 of x to the power 1/2 times x to 1/2 to the power 8 plus x to the power to 1/2 to the power 7, x to the power 1/2 to the power 6, and etc. until 1 over x to the power 1/2 plus 1. So if we plug 1, here we get 1, and on the top we get 1 9 times. So it's 9 over 2. And the bottom we get 2. So the limit is 9 over 2. So our limit for this problem is basically 9 over 2. Here we have used the fact that x to the power n minus 1 is just x minus 1, okay, times x to the power n minus 1 times x to the power n minus 2, and we keep decreasing the powers until we get to 1. This is very important in factoring and in getting rid of the problem here, the one that we had, this one here, x to square root of x minus 1. This is square root of x minus 1 that was causing this problem. So and I think this one here, and also we have used it here. So here we have used the fact that x squared minus 1 is x minus 1 times x plus 1. Okay, so this is very simple simplification of the problem for those who don't see the issue here. Okay, and I think after this we have nothing to do, and you can use L'Hopital's rule, if you know L'Hopital's rule, to get to solve this problem. Okay, so try to do it, or maybe you can bring this problem to 0 by switching x minus 1 to some other variable. Anyways, the limit here is 9/2. Thank you very much.